However, we're working out quite quickly, and part of what we're doing is recruiting people from the community to help collaborate, organize, and get things done around the subjects of AI, which I'll talk about briefly shortly. So I think just give it a couple more minutes and we probably, oh look, we've even got the right slide. So I think we're probably ready to go any moment. We are. So I'm going to hand you, yes? Oh, we got both going. Hello, the world. Nice to meet you. Fantastic. So I'm going to hand you over to Grace Pryor, the organizer of Silicon Brighton, who do an absolutely superb job of all the hard work and all the peddling behind the scenes to get all of the meetups around Brighton going. And it's been a huge resource that we've just taken for granted and depended on heavily to get these events going. So thank you, Grace and the team, for getting us up and running. Much appreciated.
Hello, thank you. And straight over to next slide, please. Ironically, I think it might be the agenda coming up, so please don't hold us too much to account. But we've hopefully all arrived and networked and chatted and everything. So yeah, hopefully you've got to know each other a little bit better. Just going to do quick intros from us about Silicon Brighton, but also this group. And then we're going to have an amazing keynote, Graham, who Martin will introduce in just a second. We do need to be out after a Q&A by 8:30 sharp. But next slide, please. We have the Old Albion about 2 minutes down the road on the other side. So if you can't get enough tonight and want to kind of carry on the conversation over a pint or a soft drink in the pub, then you are more than welcome. Next slide, please. There we go. The event has been recorded and it's been live streamed. So not just the people here in the room and also going out on YouTube and also being streamed. We'll also be taking photos as well for social. If you do not want to be included in any of our footage, absolutely fine. Please just let us know and we'll make sure that you're not on there. Next slide, please. And now I'm just going to hand over to Martin with a few comments and intro to this group specifically. Thank you.
Thank you, Grace. So last month was our kickoff event, and in preparation for that, we were trying to understand all the various categories of AI that we could and should be thinking about and coordinating. We've percolated those down into these three primary groups because then they're quite separate and quite specific and relevant to AI and what we're doing here. They are innovation and commercialization. So anyone that thinks they want to be involved or learn or understand about innovation and commercialization of AI in this community, please think about this group. And in this conversation stage, think about what you can give and want to get from that particular topic. Loads of things. You can imagine just sharing what's happening, what's cool, examples, workshops, all that kind of thing. Ethics and governance is the how to approach this in the right way. I think Brighton is a very good place to think about what the right way really is. And there's a group that's going to focus specifically on that. We were talking just earlier, we might put together a website with all the resources of best practice, law, all those matters. And in the sequence of events we'll have over the next year, every month, we'll have a particular thrust on ethics and governance, probably debates about ethics. It's a huge topic, you can imagine. Brighton and beyond, why would we do it here? I'm particularly interested in this section, and I would like to see us doing things in Brighton using AI that other people are not doing anywhere else in the world. I don't know what it is. I've had some ideas last night. We're pretty cool around the Fringe Festival. Who knows? But think about these three areas. We are actively, absolutely, definitely recruiting for people who want to be proactively involved in these areas, looking for a commitment of a couple of hours a week kind of thing to help and support. If you are interested, please find myself or any others. Graham is part of the team and others are here. I'm going to leave my business cards on this table, so if you can't find me or get to talk to me, pick up one of these and hunt me down and we can talk about how you can help. Thank you very much. So our keynote speaker today, I think he's a keynote speaker, next slide please, is Graham. Graham Cox. I've not known Graham for too long, but in my short encounter with him, he's clearly knows his stuff around AI. In fact, he was working on AI before AI was even invented. It's true. I'll let him fill in himself. Graham, over to you. Where are you hiding? There he is. Let's give him a warm welcome.
Thank you very much, everybody. And thank you, Martin, for that introduction. Okay, we have slides. Fantastic. So I will just call out for the slides to be advanced, but let's just keep it there just for 1 second. So let me just give you just a very brief overview as to why I am talking to you. So first and foremost, I am delighted to be part of the kind of steering committee for what we're doing here with Brighton AI. And to try and help get this off the ground, which I'm very excited to do. I'm a latecomer to that party, but really delighted to be in the team with Martin, Claire, BC, etc. For myself personally, I have been in artificial intelligence for literally my entire career. My degree is in artificial intelligence, and I graduated in 1990 from Edinburgh University. I can obviously sharp intakes of breath from the audience. You can't quite believe that I graduated all that time ago, but I did. And I've been working as a data scientist, as an AI developer, as an entrepreneur, and latterly as a CTO and consultant in the field of data science and AI for whatever that is now, getting on 35 years. Clearly, the subject matter was a little bit different when I started, but the principles were the same. So when I was at university, neural networks were in the process of being invented and rolling out. Okay, can we have the next slide, please? Yeah, let's have some hype just to begin with. Why not? Let's move on again. Okay, just some numbers to start off with. So the turnover of AI companies in the UK is currently reckoned to be around 42 billion a year. There's been an equivalent amount of funding into AI companies in that same period. Now, obviously, you always get the giants, the 300-pound gorillas that suck up a great deal of that money. And I have to admit that Google DeepMind is included in those figures, which does skew things a bit. But nevertheless, it's a big sum. What is interesting to me, and interesting, I think, for this group in Brighton AI, is there's reckoned to be well over 2,500 startups specifically in AI at the point that this survey was done, which is the start of this year. I reckon that figure's gone up quite dramatically since then. And I'd really like to see more of that happening in Brighton. And anything that this group can do to promote that, I think, is a really great thing. In short, it's hot. Let's move on. Thanks. Just a quick comparison for Martin and his Brighton and beyond side of things, and startups specifically in Cambridge. Again, this is start of 2023, so these numbers will have ramped up quite considerably. But at the start of this year, nearly 100 companies, 100 companies in Cambridge are AI companies first and foremost, and the vast majority of those is in the startup space. Totaling a turnover of 2.4 billion already. Clearly, that's coming mainly from this end rather than the startups, but nevertheless. Okay, and on again. And what is AI? Okay, so here we go. So Martin is acting as the ringmaster for this evening. I am effectively acting as the fluffer for this group. So I've been asked to give a kind of background on AI, and I appreciate we don't really understand this audience terribly well. I guess there are some people in this audience who are real experts in AI, and anything I say is going to feel pretty basic. There are others of you who have a real interest in AI, but don't really understand the technology at all. So trying to pitch this could be a little tricky, but we'll see what we can do. So first of all, let's get our terminology right. We talk about being data scientists. Very few people, except the ones that suddenly got into AI this year, call themselves AI experts. We tend to refer to ourselves as data scientists. And data science is a really broad church. It includes everything that you do with a spreadsheet for a start off, let alone everything that you do across business intelligence inside an organization. Data analyst jobs, first and foremost, are leading you through to data science. Its statistics are a core part of data science. However, within that, we have the area of machine learning, which is using probabilistic algorithms to to generate predictions or classifications of data that you find really hard to do with classic statistics. I'm going to talk a little bit more about that in a minute. But essentially, when you go from the statistical data through to machine learning, you're starting to deal in probabilities rather than deterministic outcomes. And then within that, we have this field of neural networks that has grown up across the last 35 years, but has really become massively prominent well, as it's come to everybody's attention in the last year or two, certainly. And a lot of the in-depth work with artificial intelligence over the last 15 years has been really focused on the development and use of neural networks. Again, I'm going to give you a very short primer on what they are in a second. Neural networks and deep learning are essentially the same thing. So when people talk about deep learning, what they're talking about is a neural network which has more layers. I'll explain that in a second. But essentially, a complex neural network is deep learning, and a shallow or less complex neural network is a neural network. So when people talk about deep learning, they are talking about neural networks. They are talking about machine learning. And then finally, when we get to artificial intelligence, we've got the woolliest definition of the lot. So my definition of what artificial intelligence is all the stuff that we think only humans should be able to do, broadly. And it's a moving target. So if we go way back to the Stone Ages, when I was at university studying artificial intelligence, I was studying the use of neural networks to recognize characters from images. And my professor at the time had started a business, and that business had sold his software to the UK government. And he was up in arms because he hadn't realized what it was going to be used for. So back at that point, we had the miners' strikes, and a chap called Arthur Scargill was organizing flying pickets to move around the country to blockade access to mines unexpectedly in order to disrupt the production of coal, which back then was a really big industry. The police had started using this technology in cameras on motorways in order to track the number plates of the flying pickets so that they could get to the mine before the flying pickets and stop them from blocking mine access. That was state-of-the-art artificial intelligence. These days, every time you drive in and out of a car park, your registration number gets read and you don't think twice about it. Do you think of that as artificial intelligence? I doubt it, frankly. It's a moving target. So back then it felt that reading a number plate from an image or a video was something really that only humans could do. It was AI. Today, we're talking about the generation of text that is as good or better than we are capable of writing ourselves, or creating images that feel like only top quality artists should be able to produce them. That today is AI. In the future, that's going to seem quite mundane and the field will move on. Essentially, AI is trying to replicate the capabilities of human being, and whatever state of the art is where that category will stand. Okay, let's move on. Okay, I'm going to keep this short, but just to go through the basics. So this is a classic picture of a neural network. It's the foundation of everything that we're doing in modern artificial intelligence. Essentially, you've got a set of inputs going through the orange on the left. They go through a set of weighted nodes that vary the data and pass data according to the weights to different nodes before things pop out on the right-hand side of the blue with an answer. Now, when you start using a neural network, you'll put the data you want in and you'll get something out that's completely rubbish. So let's say you're using it to classify pictures of cats from the internet. When you first start passing it pictures of cats and dogs and people, it's going to get a jumble out the other end and mess it up completely. What we do is use a feedback mechanism, back propagation through the nodes, which changes the weighting, these W's on that image, which causes the input data to bounce around like a pinball in different directions depending on those weights. Over time, as you get an error out the back, you see the size of that error and use that error with an algorithm to change the weights in your network. You do it again, you do it again, and over time, you start to only pop out pictures of cats from the top node and only pop out pictures of dogs from the bottom nodes, and it works. This is a learning mechanism, therefore. It's never going to be perfect. You might get it to 85, 90% accuracy and feel that you've done well. You could spend a year then getting it to 93% accuracy and the rest of your life getting it to 100% accuracy. But it's pretty good. It works well. It works as well as a human can, working with edge case images where you can only see a leg and you can't see if it's a dog or a cat or whatever. That essentially is the working of a neural network. Bunch of calculations. It's basically mathematical formulas, passing data in, transforming that data over time until you get classified output out the other side, and then using a feedback mechanism to improve that. And this is basically, at least in concept, the same way that a human biological neuron works, that we have all of these connected neurons in deep layers that allow us to learn over time by formalizing the weightings of these neurons. A deep learning network is one where there are more layers in the middle, basically. This is a 2-layer network. It's very shallow. A deep learning network might have 20 layers. That's really the only difference. Well, some tech, but it's the biggest difference. Skip on, please. Okay, and generative AI. So generative AI is what we've been really excited about this year. It's what's caused this tsunami of interest in AI, a field that I've been part of and following for most of my adult life, and actually now appears to be one of the hottest things around. I've been telling people for a long time it would happen, and it seems to have happened. Generative AI is based on neural networks. So it uses a particular type of neural network called a transformer. I won't go through the technical details of what the differences are in transformers compared to recurrent networks or whatever, but nevertheless, it is a form of neural network. So those basic principles are the same. It has some techniques associated with it that have made it exceptionally good, really quite dramatically, impressively, incredibly good at doing things like generating text. The principle of a large language model, which is the kind of the primary contact that all of us will have with generative AI, is that it predicts what the next most likely word is based on the context it's been asked to work with. It has no understanding of what it is you actually asked or the back-end meaning of that. It's not reasoning in any measurable way. It is simply using mathematical weightings in its neural network to decide what the next most appropriate word is for the question that it was asked. So it uses context, and that's what makes it feel so human-like, so artificially intelligent. The big neural networks like GPT are very impressive because they're incredibly expensive. So the training process for these large language models is really huge. There are no figures out there because OpenAI is the least open company you'll ever find. But it's reckoned that it's somewhere in the region of $100 million that it costs to train GPT-4. They have quite a lot of money. Microsoft's put 12 billion into them in total over the last few years. And they're actually making about 2 billion a year in direct revenue from OpenAI now. So they're starting to motor, but it's a huge cost behind this. And that's why we have no sign of GPT-5 coming at the moment. They're talking about GPT 4.5. And that's interesting because GPT, it seems, actually isn't one model at all. It's a collection of large language models working in a multimodal manner that are linked together so that you ask one query, it's then doing directed calls through multiple models beneath that, which is a much more cost-effective way to operate and a way that allows them to incrementally improve over time. So, and I think that is what we're likely to see from GPT specifically over time. This incremental improvement. We're starting to see the introduction of image analysis to use as context, which is another model that they've bound into it. That's available now through Bing Chat and recently through an extension on OpenAI. We're starting to see various other capabilities with the plugins and the connectors that they're building as they're building an ecosystem around this. It's a very impressive system. However, as impressive as it is, my personal belief is that the big models like GPT are not the future, or at least they're not all of the future. Back in the early days of large language models, which was what, about 8 months ago, really, in terms of commercial awareness, I was of the opinion that Microsoft, Google, OpenAI, and a couple of others were going to just clean up completely, and they were going to take all of the revenue from this, because startups essentially that are using GPT don't seem to have a lot of there's no moat. You know, if you can replace one model with another model, you're building a front end onto that system. It doesn't give you a lot of traction and competitive advantage. Actually, over the last few months, I've seen a vast upswelling in open source development in large language models, and really, really promising developments. So, hello, in this picture here, where you've got GPT-4 as the big one in the room, you have a number of other really interesting models around it. So you've got Google's Palm 2, which not surprisingly is the second biggest, but you've also got Llama, which was an open source release from Meta, Facebook, which is commercially usable with a few restrictions and is really capable. You've got Falcon, which comes from Saudi Arabia. You've got Claude, which is, and Chinchilla, which are commercial organizations, and various others coming up from there. The Llama 2, it should be, not Llama 1. Llama 2 is particularly interesting because of that open source capability. And I'm seeing specialized models with a much smaller footprint starting to come out with really great rapidity. This is important. It's important because I think the future of these models is not big generic models that try to be everything to all people. I think it's small specialist domain expert models that I believe we might even see running on our mobile phones within 2 years, that the footprint and the computational cost of running them is coming down so rapidly that we can run them on a really small footprint. Might still cost a lot of money to train them, but to actually operate them might be a lot less. Okay, let's move on. Okay, just back to basics. So AI, a primer is what we're doing. So let's just talk about the difference. So we're not writing software per se when we're creating AI. I mean, actually, my team is a team of developers, and they're developer data scientists. So they are writing code, of course, every day. But there are some significant differences in the code that we write for artificial intelligence to the code we write for software. So we write software as a deterministic requirement to solve a problem. If it solves a problem, we should be able to prove that it solves the problem all the time. It's deterministic. That's not the case with artificial intelligence. AI models are stochastic or probabilistic. They solve the problem most of the time. They're much more like people. We don't always get it right. You know, we mostly get it right if we know what we're talking about. We don't always get it right. And AI is the same. And it's very different in how you can use AI and how you have to focus your efforts if you're using it in business because of this. The example I've got there is we're very unlikely to ever be able to work out how to write a program to drive a car using a massive series of if-then-else statements. You know, it's infeasible to think of a deterministic program that will accurately deal with every scenario using a deterministic software approach. But teaching a model how to drive is entirely feasible. Entirely feasible to the extent that if you go to San Francisco, you can in fact get in a robo-taxi today, and that the UK laws for self-driving cars change in 2025 to allow them on the road, just 18 months from now. I doubt if we'll actually see very many in 18 months, but the legal ability to drive them is in place very soon. Second, well, I've talked about the stochastic versus probabilistic. So software, either it works or it doesn't. You can test it. You can do your QA. It works or it doesn't. When we're doing quality assurance and testing on AI, we're using accuracy scores. We're using a confusion matrix to understand how good is it, precision, recall, etc., etc. We are working out what percentage accuracy it is. It's never going to be very rarely going to be 100%. And when we write software, the artifact, the core thing that we're producing, the value we're producing is in the code that we produce. Whereas in AI, it's all about the data. It's all about curating that data, engineering that data, finding features in that data that are meaningful, and then running the model upon it. Okay, next slide, please. Okay, and light relief. So yeah, so it is all about data, but people that basically think you get a bunch of data, you point an AI at it, and you get a valuable output. And that's particularly become the case this year with the rise of the large language model, where there is a prevailing belief that you can basically point an AI at any set of data and just ask it a question and it's going to work. It will, to an extent. It will work at a lower percentage than you would like it to, but it will sometimes work. It is always and remains the case that if you put garbage into any piece of software, then you're largely going to get garbage out again. And so that data engineering section is absolutely crucial to coming up with any quality solution. And really, this is where the effort and the growth is in the AI field. It's around understanding and engineering data more than anywhere else. Although you've got a really interesting layer of operationalizing AI, where a lot of AI is currently in research mode, as I'd call it, which is the software's not that great, it's a bit buggy, doesn't have a lot of quality assurance about it. MLOps is not as well understood a field as DevOps. So there's a lot of improvement that we're going to see in the next few years in the quality of management and production delivery of AI software. And then we definitely shouldn't forget the fact that there are legal, ethical, and security issues around use of AI that go beyond that of normal software, because we, particularly with neural network usage, one of the features of the system is that you can't really look inside it and understand how it made a decision. All those little neurons, the nodes with their weights, they don't lend themselves to understanding why an AI came out with a particular output based on a particular input. Now, that might not matter too much if you're trying to understand why it classified something as a cat or a dog. It might matter a lot if you were using it as your recruitment software and it decided that you were going to interview person A and not interview person B. And I'm sure you'll all have heard horror stories from the net around facial recognition software that was biased towards a particular color of face or the like because of the training data that it was given. Classic example is that certainly until very recently, if you asked one of the image generation tools like Midjourney to come up with pictures of a CEO, then it would come up with a list of pictures of middle-aged white guys. Now, it doesn't do that because it's inherently racist or biased, or misogynist. It does it because that actually is the data it was given, because actually most CEOs are sadly middle-aged white guys. So it just comes out with whatever it is you give it. But that bias and the way that can affect us in society is really important. And this thread that we have in Brighton AI around ethics, bias, and social responsibility, I think is absolutely crucial. And I think it's something that we can really contribute to in the thinking of AI in our communities and beyond, because Brighton has a lot to say about this. Okay, skip on, please. Okay, let's get back to some practicality. Can we use it? Yeah, let's go again. So this is a slide I use when I'm helping organizations to think about what AI can actually do for them. So I tend to classify AI solutions into three broad areas: automation, analysis and prediction, and optimization. So the first one in automation, thank you, is I get asked people to think, well, if you had a whole load of interns, what could you do with them? What could you do now that you couldn't do easily today? So the nature of an intern is that they've got a brain, you hope. They haven't got any domain expertise, but they're capable if you just teach them what it is you want them to do. So if you had a whole load of them, could you automate tasks that currently take a lot of manual effort, or that slow down experts in your organization and stop them from being as productive and efficient as they could be. And a lot of the large language models and generative AI solutions fit into that particular category, obviously. Analysis and prediction, classic machine learning requirement. So how do you improve decision-making in an organization? Does your data lend itself to being able to find insights about the way that you operate, whether that's your cost base, your manufacturing rates, your customer churn rate, whatever it might be, that allows you to understand better what the impact of your decisions might be, and therefore to take better decisions earlier. An organization I'm talking to tomorrow has a fantastic app that is used by IBS sufferers to help them manage their symptoms and to discuss with their clinicians what it is they're going through. And they have a very rich data set that they've built up over the last 8 years. And what we're trying to do is to build a predictive model that will allow the app to predict in advance when you're likely to have a relapse, an episode of IBS, which can be incredibly painful, land you in hospital, cost the NHS a lot of money, is life limiting for the sufferer, etc. So if we could find out that what you're eating, your activity levels, your qualitative scores on how you're feeling on any given day, if that kind of data could be used to predict 8 days in advance of an episode, it could actually allow the user to take action that would stop that from happening. Great example of a predictive model. And then the third batch is around optimization and quality. So how can I do things better? So looking at operational research problems, on-demand pricing, which your airlines all use, all the things which allow you to get the most out of whatever resource it is you're working on. And broadly across any organization, when you look at where you could use AI and machine learning, it's going to fall into one or more of these 3 categories. It's not, I would point out, all just about generative AI, despite the hype that we're seeing at the moment. Machine learning solves a lot of really hardcore problems as well. Skip on, please. And when you're going through a process of working out what the right artificial intelligence projects are in any organization, these are the 3 pillars that I ask people to focus on. First and foremost, start with the value. Don't do something just because it's cool. Do it because it has a return. Do it because you can see that it can actually improve your organization. Even if you're just building a pilot, do something that will make a difference. And so starting with value to you, value to the organization, is the only way to begin. The second of those circles is then actually feasibility, and feasibility is, can it be done? So physically, does the data lend itself to do that? Do you have enough data? Is that data of a high enough quality? And can you as an organization actually deal with this? So if something involves changing processes in the organization in order to get value from it, is the organization actually willing and ready to do that? And that actually, I find, doing consultancy into mid-sized organizations, that can be a really significant block all by itself. As soon as it goes out of the tech into how it affects the organization operation, you've got a problem, particularly if it's the CTO or chief engineer who's commissioning a project. The third circle is then the ethics and legal side of things, the advisability. Should it be done? And there are not that many rules in place in the UK, although they are coming. The EU AI Act has been passed and comes into force next year, which has all sorts of implications. But then there are the social and ethical implications inside your own organization as well. If implementing an AI solution actually led to the reduction of your development team by 25%, is that something that you want to do? Is that actually the right way forwards? It's not always necessarily just about the bottom line. And move on, please. And this, what we're describing here is the process that my company, Atacop, takes people through, takes organizations through when we're looking at how we build a roadmap for AI and binding it into the organization. Take these 3 pillars, ideate what's possible, work out what is advisable, decide what is feasible, and together through those come out with a stack rank list of opportunities for AI in an organization, which get filtered and then built into a roadmap for deployment with which should be costed, have ROI associated with it, effort levels, and start with the lowest hanging fruit, the smallest project that will deliver the biggest impact. Let's just skip lightly on. Thank you. And I will then finish this bit with a shameless plug. So my company does these things. So workshops to help organizations understand what AI actually does for or can do for an organization, going through this ideation process, the development of strategy and roadmap to actually execute AI inside the organization. And then I have a data scientist delivery team who are building AI solutions, machine learning, predictive models, etc., who deliver to mid-sized organizations across the UK and a little bit further. I will leave it at that. Let's move on. Thank you. Okay, let's get back to some fun stuff. One more, please. What's going to happen? Well, I am just another guy, and I am sure your views of what might happen in AI next are just as relevant as mine. So I'm just going to give you a few of my thoughts about what I see at the moment. So first of all, the disruption is going to be huge, but the disruption is going to hit it is not going to hit the highly skilled jobs as much as people might still fear that it does. For example, I do quite a lot of AI due diligence for private equity firms and helping the private equity firm understand the effectiveness of data science and AI teams within the organization. What I tend to find when I talk to software development teams is that most of them are using Copilot solutions, so AI software development tools at some level. There's very few teams that aren't using them at all. A lot of teams I talk about are developing as much as a quarter of their code base using AI, coming from a position last year where they were developing almost none of it using AI. And that feels like we're heading towards, oh my God, that's it. 25% of all coding jobs are going to go in the next couple of years. I'm not seeing it like that, actually. What I find is that it is a great tool for senior good coders. It's a lot less useful for junior coders. So it improves efficiency and productivity for people who have got the years behind them in the experience. And actually, it just doesn't function as well. It doesn't fit into the processes of the juniors as well. So I don't see it as knocking out the whole tier of junior coders. When we look at legal, I do see it reducing the number of legal assistants that are required in an organization because information retrieval will be better, faster, more organized. But I see it improving the productivity of senior lawyers and not threatening their jobs. And I can continue through all jobs involving domain expertise. I'm seeing the same thing at the moment. It improves the lives of the experts. It's not really reducing the jobs of the people on that pathway upwards. It is reducing the paralegals, the admin requirements, the intern type requirements that come with that. And this is a McKinsey graph, and that kind of supports that as well. So the most highly susceptible jobs for being replaced by AI are in predictable, repetitive work. So we've got the robotics coming in at this end, data processing, data collection. So all those admin jobs, this is where AI can have a big impact. Almost the least impact is on everything to do with dealing with people. Funnily enough, our ability to have human interactions remains as important or more important than it's ever been. Few other line items just to finish on. The combination of AI and physical robotics, I think, is going to be huge. Again, that's borne out by McKinsey's graph here. Even if you put aside Elon Musk and his army of terrifying humanoid robots that may or may not come out in the near future, if you look at self-driving cars and come back to this 2025 legal in the UK, available as taxis in San Francisco and various other cities right now, what is a self-driving car if it's not a robot? It's an AI robot. That's what it is. We may not see AI robots hitting us in huge numbers that are humanoid in form, but they will be a major part of our life going forwards. I mentioned about the battle between these enormous general purpose AI models like GPT against the smaller, somewhat open source specialist domain expert models. And I believe that we see a rich future in that. And I would encourage people looking at innovative and entrepreneurial solutions using AI to consider how the rise of large language models and AIs that can run on small devices within 2 years could open up whole new fields and opportunities for tech and business creation. And lastly, to finish by saying, well, you know, you're not going to get away from it. Whether you're interested in AI or not, we're all going to be using it. In fact, to be honest, we're probably all using it today in some form. It is going to be part of our lives in every way. AI is a foundational technology, just as the internet is a foundational technology. You can't get away from it. And I think, can we skip on? Okay, this is my last slide. Okay, AI is not a thing, it's a concept. So when somebody says, is that AI or is that machine learning? You know, I don't know, it's up to you, really. Decide yourself. AI is not normal, it's probabilistic in nature. It will not come up with the right answer every single time, but it can do things that normal software can't. When you're planning your AI project, start with the return on investment. Don't do it just because it's cool. Work out if it's possible, and then work out if you should be doing it at all before you get started. Experiment early, get involved. The rate of change in this field is just ridiculous. I've been in tech my whole life, and it's changing every week, let alone every month. Disruptions everywhere, and build your own AI maturity. Build it for yourself, build it for the organization, because you will all benefit from it in the future. And that is me. Thank you very much.
Absolutely fantastic. Thank you very much. That was more than a primer, wasn't it? That was deep and wide and thought-provoking. So thank you very much. So we've got ample time together now to talk. First topic probably is to use Graham's time to actually ask some questions specifically about what we've covered. I wonder if it's worth stepping up a slide, perhaps on the takeaways there, because I think that might give us an aid. But the reason we're here together is because AI isn't in charge of this event. We are, and it's our job to talk to each other about these matters while we still can. So, Graham, we've got some questions, hopefully, from the audience. Grace has got the microphone. She'll pass it around.
Got one straight over here from Matt.
Thank you, Grace. So I've got to ask this question. Given that quantum computing is stochastic in nature, do you see a natural marriage between quantum and AI?
Do I see a natural marriage? I think undoubtedly yes, in that AI has the ability to model problems that you can't model in ordinary software. But I'm not qualified to say exactly how that applies to quantum, because I'm a keen observer, but not a practitioner in any way whatsoever. So I'm going to say yes, but I can't give you any specifics. Maybe you can offer one back.
I don't know if we got that long.
One of the people in the Silicon Brighton group, Sebastian, I can never remember his surname, is developing a quantum computer, vast expense for a German project. And his view is because quantum behaves a bit like humans in a hardware sense, it is very well married to AI. So if he was here, I'm sure he'd answer that more fully.
I'm sure he would.
Hi, you quite rightly spent quite a lot of time talking about generative AI during your presentation, so thank you for that. One of the things which I think is most interesting about that is the ability for the generative AI model to be able to tell the software that is using it to call out to various APIs in order to get information, in order to build a better answer. I'm thinking kind of like in chatbot kind of type applications. Do you have a particular view on that and how that will develop over time?
I think, and actually, thank you for that, because it should be on this slide and it's not. That's a major omission of my part. I think that autonomous agents, where you're building AI solutions that will go off and break down a problem into a number of sub-problems and solve each of those sub-problems independently to come back with a complete answer, is a massive area of development, and one that's really, really exciting. So, for example, if you wanted to be able to ask your personal assistant AI, order me a pizza, there's multiple steps that you would have to go through to actually be able to do that. You would need to work out where you would get a pizza from, ask what kind of pizza you want. You need to work out how to pay for the pizza. You need to work out what the address is. There's a number of different activities that have to happen to get a pizza back to the individual, unless you're working a pizza delivery app. But if you're talking about a generic intelligent agent, we don't have to just think about one thing in order to make that happen. And the ability to break a problem down into many smaller problems, find solutions to all of those, and come back with a feasible answer is a fascinating area. If you're reading in this space, you'll have read or even played with some of these tools, and people have used them with doing things like saying, I'll give it $1,000. Can it go and actually learn how to play the stock market and double, quadruple my money, etc.? And some really interesting experiments going on in that area. Thank you.
Thanks. I just have a question about your kind of overall prediction about people kind of training their own models and acting on their behalf. So, everything I say, read, kind of my actions in a day, the decisions I make, and ultimately you're repeating that process a lot of the time. If agents can autonomously act on your behalf, how close people will transition to this kind of idea that some decisions can be made for them, or some of the actions they can make will be made for them, and how, you talked about a mobile phone having open source, so the cost of that's pretty much nothing.
Yeah.
And if that can just be repeated, and as you said, a problem done on the side, just is it, to me, it seems like it's a obvious step, but people are going to like that. The privacy's kind of gone, in my opinion. Yeah, it's just any ideas.
Yeah, well, I think the personal privacy, personally, I think is we lost that battle without even realizing we were having it 20 years ago with Facebook and the like. And we've got a long way back to go in order to regain any real sense of personal privacy. But on the personal assistant side of things, I think that we greatly appreciate tools that work, that aid us in our goals, and the better that they understand us, the more we appreciate them. I think that the tools like Siri and Alexa, they're largely failing because they're not personal enough. They don't really get deep into how you operate and what you need. I actually spent 5 years of my life building a tool to understand human emotional display, specifically so that we could build a Fitbit for the emotions to track the human emotional display longitudinally over days, weeks, months, and thereby understand what mood disorders really look like by being close to that individual over a long period of time. That is a great use of AI, but it's the same as that Fitbit model, knowing that simple things, if I've done enough steps today, then at least one thing is going right in my life. I've got some personal feedback that allows me to make decisions, take better actions, so nudges, prompts, etc. And that's where I think that AI can really help with individuals. And in those areas, I think we're entirely willing to give up our information in a protected way. Again, if it's a personal assistant, you don't need to be giving your data to big corporate necessarily. It can be used personally. If the AI model's running on your phone or on your personal computer of whatever form, it doesn't necessarily need to go any further. But I'm a big believer that the symbiosis of AI and human is the way forwards. We're not going to be replaced by AI. We're going to be improved by AI.
Oh, bit of a mic drop there. Just before we go back to questions in the room, we've got one online. So first of all, that was amazing, Graham. You mentioned the ethical and transparency aspects of AI are particularly suited to our strengths in Brighton. What else do you believe we are uniquely suited to contribute? And that's Cy Conroy online.
Wow. There's a question. I should probably just throw that one out to the room. Well, what I see in Brighton, I've been in Brighton for 12 years now, having come down from Edinburgh. And what I see in Brighton is a really vibrant community that doesn't know how good it is. I see a very strong group of techs and creatives who all largely either work for London companies, they work remotely for companies elsewhere, or they work individually. We're not great at high growth startups on the whole. There's obvious exceptions and some great companies out there, but compared to the size of the population, I don't think there's that many, particularly coming from Edinburgh, a capital city where tech startup growth is really, really high. So I think that on the capability side, Brighton has an untapped potential. On attitudes, Brighton as a liberal, forward-thinking, free and easy place to be, I think it kind of leads the UK in terms of its attitudes, and the way that we could somehow take those back into trying to drive the way we want our AIs to be built in the future would be fantastic. I don't know how we do that, but I'd love to think we could have some impact.
Thank you.
Do you ever see AI becoming self-efficient to philosophize by itself, like HAL in 2000? Do you ever see that in your mind and that extension coming about?
So I deliberately avoided the topic of artificial general intelligence this evening. I didn't mention it at all. But clearly, when we talk about AI, today we talk about a tool that can do useful things for us. We have the vision, the media image, whatever it might be, of birthing a new form of intelligence, which may or may not think anything like us when we create it. I think that we need to do the right things to ensure we've got guardrails in place to manage that, in the same way that we have managed the use of stem cells in research, for example, technology that has now got massive benefits to a whole range of different conditions, but does involve manipulating the basic stuff that we're made from and can only be taken from, or until recently, only be taken from embryos. So there are very strong concerns about how we use it, but it is a tool for good. Anyway, coming back to the general intelligence, do I think it's possible? Yes, I do see a future in which we will form a new form of intelligence that is indistinguishable from the capabilities of human beings. It might actually operate very differently, but I do believe it's there. When will we recognize and how will we recognize that it is intelligence? There's an interesting moment that happened this year that didn't, I think, get an awful lot of reporting, which is that the gold standard for determining if something is an artificial intelligence or is an intelligence rather or not is something called the Turing test, which is essentially a theoretical environment where you've got two things at either end of a telephone line, so they can't see each other. There's no contact whatsoever, and the human tester is asking questions of the thing on the other end of the line to determine whether it's human or not. And that essentially, there's some rules around it. That's essentially the Turing test. Actually, large language models pass that test easily this year. There are ways to build LLMs that it's pretty much indistinguishable from the real thing. There are no successful software packages out there for telling whether something was written by an AI or written by a human. There are lots of them you could buy or get hold of. They don't work. They just don't work. The LLMs are just as good or better than us at writing text and just as creative with it, but they're not intelligence. They're not alive. So we get into the philosophical debate of what determines life and how do we build better tests for what intelligence is. Is there such a thing as a soul, et cetera, et cetera? That's probably beyond the scope of this immediate conversation, but I think we will see things that we cannot distinguish from normal intelligence within, I'm guessing, but 5 years ago, I thought it would take 30 years. Now I think it might take somewhat less than that.
I'm just wondering this black and white face thing, which I've come across with the GDP thing, because I do economics and I ask
Yeah,
it
okay.
questions. I get I get consistently from it ideological garbage, I consider it. What I've noticed is that the whole thing is conservative because it's working on yesterday's data.
Yep.
Now, I'm wondering, is there any research that is actually looking at how much this will denigrate innovation in the area of big ideological switches that we need to actually move forward, the things that drive, new technologies on? I mean, if everybody, you see what I'm saying? At the moment, I've just got the neoliberals to deal with. Now I've got a whole computer that shouts neoliberalism at me as well. Okay, so it's doubled, it's trebled, it's quadrupled, and it's a big break on innovation. So I'm just wondering how that's been.
It's a really interesting societal and philosophical debate, and I won't claim to have the answers to it. What I do believe is that I don't think that these really big models like GPT are going to dominate the world of natural language processing going forwards. And I think that specific models trained for specific use cases are going to turn out to be much more useful. The worst thing you can use a model like GPT for is a Wikipedia with a human interface. It's terrible. Just as you say, it's biased, it's got old data, it lies. It's not a search engine, and it's not the way that it should be used. I mean, Bing Chat actually does a pretty good job. Google's Palm 2 is looking better and better, but GPT itself, it's just not what it's for, and I would never use it that way. The way that I put most of my energy into using these models is by grounding the answers that it gives on a finite corpus of data, whether that be for a domain expertise, company internal knowledge, or whatever, or research data, and saying, right, you will only answer from this data. If you don't find it in this data, just tell me. I can't find anything that relates to that. That removes the lying. It then allows you to deal with bias in the way that you fine tune and train the model, and means that for that specific use case, you can remove the problem. I think you've got a really good point. When it comes to, if we treat these great big models as oracles and the arbiters of truth, then we're in real trouble, basically. But I don't think that's what's going to happen over time. I think it'll shake out.
Hiya. I was wondering if the dialogue that you encounter with organisations that you speak to, whether anyone's asking about the environmental impact of this stuff for them as an organisation.
Yes, most definitely. And again, in my rush to get through the slides and not have you fall asleep, when I talked about the advisability section, one of the 3 pillars, I didn't mention the word environmental, but the should you do it piece does absolutely have an energy cost associated with it. When particularly if you're hosting and running large models yourself, then you're running on some of these really, really incredible latest GPUs from NVIDIA that have very high energy footprints. And there is a cost associated with them. There is the direct cost, which might actually outweigh the cost of actually hiring the interns to do it in the first place. There is also the indirect cost, the environmental cost, and the potential damage that we do to the environment in the process. Again, the mitigation to that, as I come back to my prediction, is that we'll see the footprint of these models dropping dramatically over the next few years. I think now 6 months ago was an amazing time to buy NVIDIA shares. My view is that it's got a time window before it drops out of the $1 trillion market again, because once open source and smaller footprint shows its power, then we'll start to see that the world isn't all about spending all this money on massive GPU power. There's been this really interesting trend in highly funded AI startups recently, which I think there's 2 in Europe and then a whole bunch in the States. Well, they get funded to the tune of about 100 million, and they essentially give half of it directly to NVIDIA. So they invest the money in, half of it to NVIDIA, so they can get enough footprint to actually buy the GPUs they need to train their models on. it's been incredibly lucrative for this company creating these very high-powered chips. So it's a really good point. Yes.
Hello.
Hi.
I wanted to know roughly. So we said the language models are not yet at the point where they kind of are similar with humans. They do a lot of stuff well, but it's like kind of they're doing it probabilistically. They don't really understand what's going on.
Yeah.
What are like other kind of things that humans can do and that AI cannot do yet?
Yeah. Well, so humans arguably, there are humans out there that can do most things are better than AI can. You know, so even when it comes to playing chess, there are some humans out there that can get pretty close to the performance of an AI some of the time. I mean, I can't. Probably you can't as well, unless you're a hidden grandmaster. But some people are out there that can. On the whole, AIs can do a whole bunch of automation jobs better than the average human being. You know, so like they can, the large language model can write better English than I would guess most of the people in this room. I'm sure some of you are fantastic. You've got books. You're absolutely amazing. But most of us, LLMs will outperform. And it's you know, across the remit of everything that an AI can do, that tends to be true. Humans specifically are infinitely better at everything that involves dealing with other humans. So that human interaction piece is an area where I don't see AI really having a big impact at all. So human management, the human side of the whole medical profession, et cetera, it's you know, massively out of the scope of AI. And things that require a human body to do easily are going to be uneconomic for AI and robot combinations to do for a long time to come. If that's an answer, then that's it.
So we've got time for 2 more questions, I think. We've got a couple of more minutes left.
Yeah, it was just a comment just to say that, in fact, AI models, there's been research done to show that patients find them more empathetic than medical officials. So it's not the case. It's not the case that humans are better at managing humans all the time. And I think a lot of people have actually said that ChatGPT is a very empathetic tool and it's developing qualities which not all human beings easily have.
That is true, but the lack of ability to question GPT's reasoning makes its use in those scenarios infeasible, because if it was to be used to actually provide advice rather than just provide reassurance, then the implications of the decisions that it makes are pretty high. And at the moment, I can't see that being approved for any kind of medical diagnosis. And this comes from, I have actually spent a year working with a company that produces AI software for acute clinical diagnosis, so for use by nurses and frontline ambulance personnel. But I agree that GPT produces just fantastic English, that it can appear very empathetic. And I recognize the study that you referenced as well, absolutely.
Brilliant. And a final question.
Hi. Everyone seems to be worried about AI becoming sentient as some kind of tipping point. Do you think that is something we should be concerned about? And if so, how far in the future do you think that is? How close are we to that point?
I think it's absolutely something that we need to be prepared for, because I think I'm absolutely convinced it will happen. And I think the way we need to be prepared for that is to understand how we want our AI to behave. And that fundamentally comes down to the way that we prepare the data sets and the way that we prepare training for the AI as a starting point. So that, you know, what the steps required to produce sentient AI, I don't know what they are, let's not go into them. But in order to produce AI that has the right bias, that is inclined to be a supporter of humanity and not a replacement for humanity comes down to the way that we approach the whole subject in the first place, the way that we train, the way that we develop. And I think those guardrails absolutely should be in place. So going back to my comments around, comparing it to use of medical techniques like stem cell research and the like, we must have that regulation in place. We're reliant on the governments to bring that in first and foremost. And then for AI researchers to be forced to behave to those standards. We can't impose that across the world, of course. How China behaves is entirely up to them. And we may see quite a bit of conflict in that area going forwards. AI-related cyber warfare is a major concern of mine. So that's moving back away from the sentience, but back into the ethics and behavior side of it. There's some existential threats that exist well before we start creating Skynet, basically.
Thank you.
Brilliant. I think we've given Graham quite the grilling, so should we give him a huge round of applause?
Wow. Yes. Thank you. Super job, Graham. You set an extremely high bar. Just to make a few comments to wrap up, if we could jump a couple of slides through, please. Just jump a couple of slides, step through, and one more. Another slide. One more. So the point I want to make is just to introduce you to a couple of other people that I'd like you to get to know. Claire, Matt, BC, perhaps just jump up and down and wave your arms around a little bit. So each of these people, with Graham and myself, are currently part of the Brighton AI organisers team, this lot. Think about, pick a slide, think about each of those 3 domains. We want you to contribute. If you want to be a part of this thing, AI, and have a meaningful input and output to it, please contribute. Please find us. We can absolutely make use of your skills, knowledge, talent, and effort. If you're not sure how to find us, there's some QR codes to scan. I've put my business cards on the table here, so please pick one up, hunt me down, and we'll start a dialogue, and we'll organise people into these work groups and start some specific initiatives to deliver, understand, practice, and be very proficient at AI in Brighton. I think that's our real objective. So thank you all for coming along. Much appreciated. Have a good evening, and I think we'll see you in the pub, which is 100 yards down the road on the right. Thanks very much.
I'm going to go back to Grand Parade and then go down there. You might see that tomorrow or something. I'm going to go and do a Grand Parade down there. Yeah, I've just got to go and do. I forgot to put my bloody invoice in for today, so I'm hoping I won't mind it being a couple of hours late. You know, it's usually by midnight. Okay, all right. Well, I'll be getting back with my list. Oh, what is the message? Yeah, I think so. Yeah. I've probably got it anyway. Yeah, but I've got you on the WhatsApp. So you can get the jet speed. Don't worry. Yeah. The system's on tape. But yeah, do you want to just tell me? Yeah. And then when I finish, if you're about fine, and if not, maybe tomorrow. Yeah, tomorrow. Yeah. So 0777 056. Cool. Well done. So I'll do it when I'm outside though. I'm glad I came down. No, it's really good to sort of see that. I think there's another direction as well with this stuff. You know, that's very like business. So I think there's a creative side that, like you said, there's not a lot of tech up there. That's very tech. I think there's more creative. We've just started an agency yesterday, so we got loads of companies that just want imagery developed and stuff. So not so much like doing the large language model, but a large sort of image model. It just saves them a fortune on doing work, you know. So then I think a lot of companies are very quick off the mark to make sure that they offer something that's yeah, they're certainly good. I mean, we just started English forestry and doing stuff with them, so it's kind of and a documentary coming up with AI in it and stuff like that. But I'm going to do this bloody invoice. And I want to get it in. But we'll talk. Identify the right sort of people. It's very different.